redox reactions, oxidation and reduction. Now, when you are in junior classes, class 9, class 8, you learned briefly little bit about oxidation, what a little bit about reduction. Oxidation you have learned is gain of oxygen, loss of hydrogen, and reduction you have learned as reduction as what? Tell me. Loss of oxygen and gain of hydrogen. In terms of oxidation, oxygen and hydrogen. Now, in class 11, you'll be learning in detail about oxidation and reduction or redox reactions in terms of electronic concept as well as in terms of oxygen and hydrogen. Okay. Now, here, let me give you some examples. Let me give you some examples according to the electronic concept, which will be required more frequently in this class 11. Okay. Now, let us say, let us say I write atom, magnesium atom. I put an arrow. I make magnesium ion. Now tell me, how is this possible? How is this possible? How can magnesium atom become magnesium cation? Tell me. Is it possible by giving electrons or losing electrons by the atom? Anybody? How can you make magnesium atom into magnesium ion? This is Mg plus 2. This is Mg plus 2, magnesium ion.
Loss of electron.
Loss of electrons. So, magnesium atom loses electrons. How many electrons? It loses
Two.
it loses 2 electrons.
Two
So,
electrons.
I can write minus 2 electrons above the arrow here. I can write this minus 2 electrons either above the arrow, or these 2 electrons I can write on the product side like this, plus 2 electrons this side. So, this magnesium atom has lost 2 electrons. So, this is oxidation. This is oxidation. Oxidation. Okay. Now, similarly, let's do another example. If I take an atom of oxygen, and to this atom of oxygen, if I give 2 electrons to it, this is an atom of oxygen. It is a non-metal. So, if I give 2 electrons to an atom of oxygen, it is going to become O minus 2 ion, oxide ion. So here oxygen atom has gained 2 electrons. It has gained how many electrons? It has gained 2 electrons. So this is a case of what? There is gain of electron. This is a case of reduction. This is reduction. Okay.
Sir, are you showing screen?
Hello?
Sir, are you sharing screen?
Yeah.
Sir, we cannot see.
You cannot see. The screen
No,
is
sir.
shared.
Yes, sir.
Okay.
Yes, sir.
Just a second. I'll check my settings over here. Just check now. Is it coming? Is it coming now?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes. Okay. Can everyone see the screen now? Yeah.
Yes, sir.
I think you can see now.
Yes, sir.
Yeah,
Yes,
indication
sir.
is coming. Okay, good. Very good. Now, redox reaction, unit 8, oxidation and reduction. Okay, so I think I'll repeat this once more. An atom of magnesium losing 2 electrons, it is becoming Mg plus 2, magnesium ion. This is oxidation. Whenever there is loss of electron, it is oxidation. And in the case of oxygen atom, it is gaining 2 electrons. It is forming oxide ion, O minus 2. And that is reduction. Okay. Now the same thing, my dear boys. The same thing. If I write magnesium electron dot diagram, magnesium has 2 electrons in its outermost shell, and then oxygen atom has six electrons in its what you call valence shell. So magnesium plus oxygen will give me magnesium oxide. Will give me what? Magnesium oxide. One, two, three, four, five, six, and 7 and 8. Or this can be written as twice Mg plus 2 O minus 2. Now look at this reaction very, very carefully. Let me explain this. When magnesium, a metallic atom, combines with oxygen gas, which is a non-metal, each oxygen atom has 6 electrons in its valence shell. And here this is a molecule of oxygen. So here what is happening? The magnesium, one magnesium, it is giving 2 electrons. So we need to balance it. So two magnesium atoms will give a pair of electron each to the oxygen atom in the molecule, and that is how it forms magnesium oxide. So magnesium is losing what? Electrons, and the oxygen atoms are gaining electrons. So in this reaction, both both oxidation oxidation and reduction are happening. Both oxidation and reduction are happening. That is why this reaction is called redox reaction. It is called redox reaction because this oxidation and reduction are happening at the same time. So this is an example of redox reaction. Okay. I think this much it is clear to all of you. Okay. Now let me give you another example. Say I react zinc metal, okay, solid zinc metal with say dilute hydrochloric acid HCl, aqueous solution state. So this reaction is going to happen, and it is going to produce zinc chloride in the solution, and hydrogen gas is going to be formed. Okay. So this is one another example of redox reaction. Let me explain this. So when zinc metal, which is reacting with hydrochloric acid, from this hydrochloric acid you can see in the solution we can take out the hydrogen ions, two hydrogen ions. There are two hydrogen ions. Are you getting it? Two hydrogen ions in aqueous solution. So these two hydrogen ions, H plus means they are short of one electron each. One hydrogen ion is short of one electron, so two will be short of two electrons. So this zinc, its oxidation number, its valence is plus 2. It has two electrons in its valence shell, so it is going to give one electron each to these two hydrogen atoms. So that is how after losing two electrons, this zinc metal, it is becoming zinc ion in solution, and that's how hydrogen ions are going to gain electrons and combine among themselves to form hydrogen gas. Okay, so here in this reaction, the hydrogen ion is receiving electrons, and the zinc metal, it is giving away electrons. So this is also an example of a redox reaction. It is also an example of a redox reaction. Okay, I think this is clear to you now. Okay, the second example. Okay, let me give you a few
So,
more. Yes,
so can you explain the second example again?
this one. Second example.
So,
Yeah,
yes, sir.
this one. Okay, zinc is a metal. No?
Yes, sir.
Yes or no? Now we know the valency of zinc is how much? Plus 2, no?
Yes, sir.
Which means zinc metal can give away two electrons, no? Can zinc
Yes, sir.
metal give away two electrons? Its
Yes, sir.
valence is plus 2 means it can give away two electrons. So from hydrochloric acid, from hydrochloric acid, to HCl, we have two H plus ions. two H plus ions. Okay, so one electron is being given to this H plus ion, the other electron is being given to this H plus ion. Are you getting it?
Yes, sir.
Are you getting it? Yes. Okay, very good.
Yes, sir.
Now, altogether, this zinc metal, it has lost two electrons. So that is why it now becomes an ion carrying a plus 2 charge. This is zinc ion. Whereas
Oh,
the hydrogen ions, they have received one electron each to become stable, to acquire the electronic configuration, to become stable. Hydrogen atom
yes, sir.
with one electron each. Now these two hydrogen atoms, they combine with each other by means of covalent bonding, and that's how hydrogen gas is formed. Are you getting it now? Are
Yes,
you getting
sir.
it now? So here we can see the zinc metal has lost two electrons, given away two electrons, and the two hydrogen ions, they have received one electron each. So there is loss of electron here. There is loss of electron here.
Yes, sir.
Loss of electron by whom? By
The
zinc,
zinc.
zinc metal. And there is gain
Yes,
of electron by whom?
sir.
Gain of,
Hydrogen.
yes, gain of electron by H
Hydrogen.
plus ions. So wherever there is loss of electron, whoever is
Yes,
losing the electron, that is oxidation. That is oxidation, correct?
yes, sir.
And whatever is gaining electron, that is what?
Reduction.
Reduction. Now I think this is clear, no? Clear,
Yes,
no?
sir.
Okay, very good.
Sir, thanks, sir.
Very good, very good. Now, let us go to another example. Let us go to another example. Okay. I will take an example where zinc metal, zinc metal is reacted with copper sulfate solution. Copper sulfate solution. Zinc metal is reacted with copper sulfate solution. Now, in your class 8 and 9, you must have learned the activity series of metals, no? Yes? Activity series of
Yes, sir.
Yes, sir.
metals. When you are in class 8, you learned activity series of metals K, Na, Ca, Mg, Al, Zn, Fe, Pb, H, Cu, Hg, Ag, Au, Pt. Isn't it? Yes or no?
Yes, sir.
Yes, sir.
Yes. This is the activity series of metals which you have learned in class 8 also, revised in class 9 also, and you are supposed to remember this in class 10 also. So, using this activity series of metals, I will just explain you the reactivity. The metals which are placed at the top are more reactive, are more reactive than the metals which are placed at the bottom. Are you getting it? Are you getting it, all of you? Yes?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So
Sir,
now, according to class 8 and 9 concept, if you perform this reaction, if you perform this reaction, this zinc metal, if you look at zinc metal and the position of copper metal in this series over here, copper is here and zinc is here. So which is more reactive? Which is more reactive? Tell me.
So zinc.
Zinc,
Zinc.
obviously. Zinc is more reactive. So this zinc metal, it is going to displace, kick out copper from copper sulfate solution. Then, after displacing copper from copper sulfate solution, the zinc metal is going to form zinc sulfate and copper metal is discharged. So, this is happening over here. The reason is zinc metal, it is more reactive than copper. That is why it is able to displace. It is an example of simple displacement reaction. It is an example of what? Simple displacement reaction. Are you getting it? Have you heard the word simple displacement reaction in class 8
Yes,
and
sir.
9? Very good.
yes,
So
sir.
now,
Yes, sir.
using this simple displacement reaction, my dear boys, okay, I'll explain you how this reaction is a redox reaction now. Okay, now let us have a look. I'll write this above equation in an ionic form. Zinc is a metal, so right now its valency is 0. Okay. Copper is a metal, but it is in the combined state with sulfate. So in copper sulfate, the valency of copper is plus 2 and the valency of sulfate is minus 2. Are you getting my point? Are you getting my point,
Yes,
boys?
sir.
Yes, very good. Similarly, on the right hand side, zinc sulfate. In zinc sulfate, the valency of zinc is plus 2 and sulfate it is minus 2. This is copper metal, so its valency is 0. We write 0. Okay, oxidation number 0. Okay, metal, it's stable. Okay. Now this equation is an example of a simple displacement reaction. Using this equation, I am going to explain you redox reaction. Okay. Now I am going to write this equation once more. Zinc metal. Okay. Zinc metal plus, I'll write only the metallic part. Copper ions from where? Copper ions from copper sulfate solution, which is in the solution, aqueous solution. Okay. So zinc metal plus copper ions. Now see what is happening. This zinc metal, it will give two electrons to this copper ion. It will give two electrons. After giving two electrons, after losing electrons, the metals become cations, no? The metals become cations. That is how this zinc metal is becoming Zn plus 2 in aqueous solution. In aqueous solution, I am not writing the SO4 minus 2 part. It is there combined with Zn plus 2. And over here, this copper ion, it has gained two electrons, so it will become metal. It will become metal. Now see, this zinc, it is becoming Zn plus 2. How does it become Zn plus 2? By losing two electrons. Correct? Can you follow me? This zinc metal,
Yes.
it is becoming zinc ion by losing two electrons. There is loss of electrons. There is loss of electrons. Correct? And the copper ions from copper sulfate solution, the copper ions are taking those two electrons, plus two electrons. There is gain of electrons, gain of electrons, and it is becoming copper metal. So one side you can see zinc metal is becoming zinc ion. There is loss of electron. Loss of electron means it is oxidation. It is oxidation. Correct? No? Loss of
Yes,
electron
sir.
means oxidation. Loss of electron means oxidation. I am repeating several times. Okay. Now, on the other side, this copper ion, it is gaining two electrons. So, gain of electrons, it is reduction. It
Reduction.
is reduction. Is it clear now? Is it clear now? Is it
Yes, sir.
clear? Is
Yes,
this
sir.
example clear? So, can we
Yes,
call
sir.
this reaction, which is a simple displacement reaction, as an example of redox reaction?
Yes, sir.
Redox reaction, because both reduction and oxidation are happening simultaneously. They are happening simultaneously at the same time, one after the other, isn't it? Are you getting it, boys? Are you getting it?
Yes,
Yes,
sir.
sir.
Okay. Now,
Yes, sir.
yes, you have got any question? Anybody? No question. Okay. Now, now this reaction which I have just written down over here, Zn metal, zinc metal plus Cu plus 2 in from aqueous solution, it is forming Zn plus 2 zinc ions after combining with sulfate and copper metal. Okay. In this reaction, this zinc metal, it is losing electrons. It is losing electrons. So the metal which is losing electrons becomes an agent, and it is called reducing agent. It is called reducing agent. It becomes an agent and it is called reducing agent. Whereas the copper ion, it is receiving electrons, it is accepting electrons. So this copper ions acting as the oxidizing agent. Oxidizing agent. Please keep this in mind. So whoever is losing the electrons, they are acting as the reducing agent, and whoever is accepting the electrons are acting as the oxidizing agent. Am I clear?
Yes, sir.
Anybody any question? Anybody any question? When zinc metal is becoming zinc ion, it is losing two electrons. The process is oxidation. The process is oxidation. When zinc metal is losing two electrons, the process is oxidation over here. But this zinc, it is the agent, it is the reducing agent, because it is giving electron to somebody who is getting reduced. Okay. Similarly, if you look at copper ion, the copper ion is the oxidizing agent, supposed to be the oxidizing agent, but it is receiving electrons. It is receiving two electrons, and the process here, when it is receiving electrons, it is reduction, but itself it is the oxidizing agent. So this has to be very clear in your mind. This concept is very important today. Okay. Without this concept, there are so many things which you cannot get properly in this chapter. So make this point very clear today, my dear boys. Okay. The metals, the substances which are losing electrons, giving away electrons, the process oxidation, and that substance, that metal is the agent, reducing agent. Whereas the substances or the ions which are gaining electrons, receiving electrons, the process happening is reduction, whereas the substance itself is an oxidizing agent. So make this example very, very clear. It's important. Okay. Now, the other thing which I would like to tell you is it is possible to split these two reactions into two half reactions. Two half reactions. The first one, it will be called oxidation. Oxidation half reaction. Oxidation half reaction. Now, which is the oxidation half reaction? This part. This part. Okay. So this oxidation half reaction for the above reaction can be written like this: ZnS, just an arrow, and I can write over here Zn plus 2. Okay. And then here I can put the electrons, minus 2 electrons here, this way. This is the oxidation half reaction. Okay. Similarly, I can write down the other half reaction, which is called reduction half reaction also. Reduction half reaction also. Now for the reduction half reaction, copper ion Cu plus 2, it is gaining 2 electrons. It is receiving 2 electrons and it is becoming copper metal. Okay, copper metal, that is the solid over here. This is in aqueous solution. Okay, are you getting it now? Okay, so this is how
Yes,
you have
sir.
to understand a redox reaction. Loss of electron, oxidation, but whatever is losing electron, that is the reducing agent. Gain of electron is process is reduction, and whatever is gaining electrons itself, it is the oxidizing agent. Okay. Okay. Anybody any question? Anybody any question?
No, sir.
Got it? Okay. Now shall we go
Yes, sir.
further? Shall we go further, boys? If
Yes,
you
sir.
Yes, sir.
if you have understood till here, then I can go further. Okay. Now, now I am writing one question for you. Okay. One question for you. Okay. You also write it down if you have your exercise copies over there. Split the following. Split the following redox reactions. Redox reactions into two half reactions. I'll give one only one. Okay. Sn plus 2, Sn plus 2, stannous ion plus twice Fe plus 3. Okay. Arrow Sn plus 4 plus twice Fe plus 2. Look at this. It's a wonderful example. Sn plus 2 is becoming Sn plus 4. So this is one question I expect you all to copy it down and let us solve it together. I solve, you also understand and write down the solution for it. Okay. Now, have you all copied this equation, ionic equation? This is called an
Yes, sir.
ionic equation. Ionic equation. Am I clear? It is called an ionic equation. What equation? It is called an ionic equation. Are you getting it, boys? It is
Yes,
called
sir.
what? Ionic equation. Okay, good. Now,
Yes, sir.
now Sn plus 2. Sn plus 2, it is becoming Sn plus 4. How does plus 2 become plus 4? Is it by losing electrons or gaining electrons?
Loss of electron.
Loss of how
So
many
losing,
electrons?
Loss of
losing.
Yes, very good. So
So
Sn plus 2, it is losing 2 electrons, correct? Can I write it over there? Sn plus 2 is
yes, sir.
losing 2 electrons. So loss of electron means what? Oxidation?
Oxidation.
Oxidation. Okay. This is the first working you have to do. Then now look at Fe plus 3. Fe plus 3 over there. Fe plus 3, Fe plus 3, there are two of them. Fe plus 3 is becoming Fe plus 2. Fe plus 3 is becoming Fe plus 2. So how can you make plus 3 into plus 2? By
gain of
By
electron.
gaining.
gaining electrons. How many electrons?
So one.
One,
One. But there are two atoms over here, no? Two, no? Two of them, no? Altogether, how many electrons you have to give?
two.
Fe, yeah, you have to give two electrons because there are two ions of Fe plus 3. So that's why you have to give over here two electrons. So here Fe plus 3, two ions of Fe plus 3 are gaining altogether two electrons and they are forming two ions of Fe plus 2. Fe plus 2 is ferrous, Fe plus 3 is ferric. So here, wherever there is gain of electrons, it is reduction. It is reduction. Is that clear? Is that clear?
So yes,
Okay.
sir.
Now we get the answer. Now we have to write down oxidation. Oxidation half reaction. Oxidation half reaction. Underline it and write down the half reaction part. Sn plus 2 minus 2 electron arrow Sn plus 4. This is the oxidation half reaction. And similarly, below that, write down reduction half reaction. So below this reduction half reaction, write down twice Fe plus 3 plus 2 electrons. Arrow twice Fe plus 2. That's it. I think the concept is very clear to all of you now. Yes or no? Yes or no? Anybody?
Yes,
Both are
sir.
Yes.
getting it? Yes, very good. I'm happy with that. Since there is a yes from the other side, I'm very happy with that. Okay. Is that clear? Is that
Yes,
clear?
sir.
Yes, sir.
Yes,
Okay.
sir.
Good.
Uh,
Now, in class 11, there is a new term for you all, which is called oxidation number. Which is called oxidation number. It is called oxidation number or oxidation state. Oxidation state. Okay. Now, this I will explain you. Okay. Now, listen carefully. Like redox reactions, you already got the idea. No? The redox changes that we have studied so far. I showed you there is either loss or gain of electrons, that is transfer of electrons from one species. From one species, it can be metals, it can be non-metals. Okay, metallic species, they were losing electrons, and non-metallic species or ions, they were gaining electrons. So that was case of redox reactions. Now this electron transfer can be explained in terms of another word over here, a new term which is called oxidation number or oxidation state. Okay, so that's how we have a new definition today for all of you. So I'm telling you the definition, listen to it. Okay, listen to it carefully. No need to write it down. Oxidation number or this oxidation state. Oxidation number or this oxidation state. It is defined as the charge. It is defined as the charge that the atom appears to have. Like for example, if we have say Fe plus 2, we can have Fe plus 3. We can have O minus 2. Are you getting it? So these charges carried by the species, these are called the oxidation number or oxidation states. Okay, it is not difficult at all. Are you getting it? Are you getting it? Yes,
yes, sir.
Yes,
that is
sir.
very simple. Now,
Yes, sir.
now I will just give you a few examples with respect to this oxidation number and oxidation state. Okay, examples. Examples. The examples are like this. Now, say, let's take first one, water. Water. Now, in water, there are two hydrogen atoms. Are there two hydrogen atoms? Yes. In water molecule there are two hydrogen atoms. And how many oxygen atoms? One.
One.
Hmm. So what is the over here in water molecule? What is the valency of hydrogen? Tell me. What is the valency of hydrogen?
Plus two.
Not plus
One.
two. It is one.
One.
Valency of hydrogen is plus one. It is plus one. So here in this example of water, oxidation oxidation number of hydrogen is plus 1, and oxidation number oxidation number of oxygen is minus 2. Valence is minus 2, no? So it is minus 2. So the valency which you have learned in classes 8, 9, 10, those are called, the charges are called the respective oxidation number with their respective sign, plus or minus. Plus over here it is minus. Are you getting it? So from the formula, oxidation number of hydrogen is plus 1, oxidation number of oxygen is minus 2. If you look at another example, this was example 1. Look at the other example. Let us take H2SO4. This is sulfuric acid. Sulfuric acid. Now here we can work out very easily. Work out very easily. Oxidation number of hydrogen, it is plus 1. Okay. Oxidation number of oxygen, it is minus 2. But how will you get the oxidation number of sulfur? What is the valency of sulfur? Sulfur has variable valency. So that has to be worked out over here. Okay. So I will show you the working to get the oxidation number of sulfur. Sulfur we don't know. Question mark, we don't know. Let us calculate now. This is what I want to teach you now. Okay. So hydrogen we know it is plus 1. So I write down over here two atoms of hydrogen into plus 1. Watch very very carefully. Plus sulfur, how many atom in the formula? One atom. We don't know the oxidation number of sulfur, so I write X over there. I write X. Let it be X. Okay. Plus how many atoms of oxygen? There are 4 atoms of oxygen. So 4, and its oxidation number is minus 2. Okay. This is equal to sulfuric acid is a neutral, it's a molecule. It is not carrying an overall charge. The overall charge carried by sulfuric acid is neutral, it is 0. So that's why I put a 0 over here. Okay. Now this can be simplified very easily. 2 plus x, 4 to the 8 minus 8, that is equal to 0. Or x is equal to this minus 8 goes that side. Just check over there. 4 to the minus 8. Correct, no? Minus 8 plus 2 gives what? Minus 6, no? Minus 6. So that goes that side, minus 8 becomes plus 6. So the oxidation number of sulfur we're getting plus 6. Are you getting it? All of you?
Yes, sir.
Okay. Now let's talk about an ion. Okay. Let's talk about an ion. Example. Let's say SO4, sorry, one more minute, few more minutes. Okay. SO4 minus 2 ion. Okay. Let's find the oxidation number of sulfur. Okay. Let it be X. One atom of sulfur, 1 into X, plus there are 4 atoms of oxygen, so 4 into minus 2, because oxidation number of oxygen is minus 2, that is equal to the overall charge carried by the sulfate ion is minus 2. Minus 2. So there, after the equal to sign, I put minus 2 over here. Are you getting it? Now 1x minus 8 is equal to minus 2. So x will be equal to minus 2 plus 8, that is coming as plus 6. Are you getting it? Are you getting it? This is how we get
Yes, sir.
oxidation number of a given element, from its radical or ion. Okay. So I think it's already time. So now, my dear boys, I will just take the attendance before leaving the class. Okay. Just hang on. Don't leave the class. Okay. Good. Now, what class do you have next period?
So maths.
Maths. Okay. Okay. Now, hello.
So
Yes, sir.
Yes. Now you may leave the class. Okay, boys.
Thank you, sir.